For our project, we are going to create a sticky inelastic collision between two wooden blocks. We're going to calculate the initial velocity of the first block right before it hits the second block. In real life, this could represent a car crash. We will show you on a smaller scale how police may use physics to find the initial speed of a car right before impact. An inelastic collision is a collision where two objects collide into each other and they stick together. In our example, one block will be pushed with an initial velocity and the second block will be at rest. The moving block will hit the stationary block at the center of mass, so there is no rotation after the collision. The two blocks will stick together and move together for some distance. To calculate the initial velocity of the moving block, we must first solve for the final velocity of the two-block system right after the collision. To do this, we will use kinematics and Newton's second law. The final velocity in the equation will be 0, and we will solve for the initial velocity, which will be the velocity right after the collision. We must also solve for acceleration too, so we'll use Newton's second law for this. The only force acting on the block while it slides is kinetic friction. Therefore, kinetic friction equals ma. Kinetic friction is coefficient of friction times mg equals ma. To solve for acceleration, both masses will cancel out, and the equation will be uk times g. And for the initial velocity, it will end up equaling the square root of 2ax. So now that we have two equations, the v0 equals 2ax, which we solve by kinematics, and acceleration, which we solve by Newton's second law, we can substitute in the formula for a into v0, which will be v0 equals square root of 2 times coefficient of friction times gravity times x. We got our coefficient of friction of 0.35 from an online source called engineeringtoolbox.com. So that is the coefficient of friction between two pieces of wood that are dry. You saw in the video that the distance the blocks traveled after the collision was 0.13 meters. So after all of our given values, we'll get 2 times 0.35 times 9.8 times 0.13. This will give us a value of 0.94 meters per second for the velocity right after the collision. Now we will use the conservation of momentum to solve for the initial velocity of the first block. In the first part of the equation, the only moving part of the system is block 1, so the m2, v2 cancels out. Both m1 and m2 had the same mass, so the equation is simplified to m1 v1 equals 2m vf. The m's can cancel out, so you will get v initial of the first block equals 2vf. We solved earlier the final velocity of the two block system right after the collision, which was 0.94. So now we can plug that into the equation, and we will get that the initial velocity of the first moving block was 1.88 meters per second. By calculating the initial velocity, cops can use that information to determine if someone was speeding before the collision. Cops can also determine the exact spot of where a crash took place by using Newton's second law and kinematics in a similar way that we did. This next video we're about to show is a simulation of what a crash would look like if both cars are moving at the point of impact. You can use this new conservation of momentum formula to solve for one of the initial velocities of the cars. You need to know one of the initial velocities in order to do this. When the collision occurs, the two-car system will not move in a straight horizontal line like our example did. they will move at an angle since both cars are moving at impact. By applying these physics principles, you can use them better to understand many different scenarios, such as shooting a bull out of a gun, a football player tackling someone, or billiard balls. Thanks for watching.